have, and I'm going to use black ink, the function is h of x, y. This brush is too thick, let me make it thinner. Is equal to h of x, y is equal to e to the x sine y is equal to e to the x, a little too thin, sine y. Okay, so this is the function that I'm dealing with. And they want me to find the directional derivative at the point P1 of so find the directional derivative in the direction of v equals to negative I. So v is going to be equal to negative I. That's the direction, right? So this is the direction. Okay, and they want me to evaluate this at the point. They want me to evaluate this at the point p 1 pi over 2 and evaluate at the point okay, p 1 pi over 2. Okay, so I'm going to do this. So we know that the directional derivative, first of all, this over here, p is equal to negative I, is already a unit vector. So note, so this is the solution. Okay, so this is the solution. Let me actually, so solution. So note that okay, v equals to negative I is the vector. This is the vector negative 1, 0. Therefore, thus, okay, if I take the norm of this, it is of norm 1, right? It is of norm 1, or magnitude 1, if you will. Okay, how do I see that? Well, let me take the norm of the vector. This is just going to be equal to negative 1 squared. Okay, plus 0 squared. And I'm taking the square root of that. Sorry. I'm taking the square root of that. And of course, this is just going to be equal to the square root of 1. So this is equal to 1. So the norm of this vector is 1. So right away, I actually know that that I don't have to actually normalize or make this vector of norm 1, the vector v. H of xy, we know that du of h of xy is equal to the gradient of h dot product it with the vector u. But here, so this is really, in our mind, because we're working with v is equal to negative I, this is going to be the dot product of the gradient of h with, okay, this vector. So, you know, we're letting here, of course, we're letting here u is going to be the vector v, which is going to be the vector, of course, negative 1, 0, and this, of course, is just a vector of magnitude 1, okay, as we saw above here. All right, so let's find the gradient of the function. Let's find the gradient of this function h of xy, and this, of course, here is really a dot product. So let me go back to this color red. So this is equal then to, let me find the gradient of h, the partial of this function h of xy in respect to x, okay, is going to be equal. So I have to find the partial of this function in respect to x, h of xy. Well, that's just going to be equal e to the x, and we have the constant psi y here, sine y, sorry. And then I have to find, so this is really the partial of this function in respect to x, so it's just really h1. Okay? And then I have to find the partial in respect to y. So it's just going to be e to the x times cosine of y times the derivative of y, but the derivative of y is just 1. Okay, so this is what I have, and now I take the dot product of this with negative 1, 0. Okay, so let's see what I end up with. What I end up with is e to the x, okay, sine y negative, because I'm taking the dot product of this, so it's going to be this times this plus this times 0. Well, I might as well forget about this times 0 because it just becomes 0. So this is what, okay, this is what du of h of xy is equal to. So this is the directional derivative of the function h of xy in the direction u, and of course where u is equal to the unit vector negative 1, 0, okay, which was given to us as a unit vector anyway, so we didn't actually have to divide by the norm of v, so that's fine. Alright, so now the problem also asks for what this thing is equal evaluated at. They want us to evaluate, so they want us to evaluate du h of xy. They want us to evaluate this at the point, okay, at the point 1 pi over 2. So I'm going to write it over here, 1 pi over 2. So let's see what this is going to be equal to. Well, this is going to be equal whenever I see x, I substitute a 1, and whenever I see y, I substitute pi over 2. So du of h of xy evaluated at the point 1 pi over 2 is going to be equal to negative e, okay, to the 1 sine of pi over 2. Okay, well, sine of pi over 2, let's see how I do that. Okay, so we have the unit circle here. The angle pi over 2 is this one, and if I take sine, okay, of this angle, I am looking the angle pi over 2, which is let's say right here. This is the angle pi over 2. So the sine of pi over 2 is the y-coordinate of this point on the unit circle. Okay, so the y-coordinate of that point on the unit circle is going to be equal to 1. So really, this thing over here, is just going to be equal to negative e sine of pi over 2, which is equal to 1. So it's just going to be equal to negative e. So this is your answer. Alright, so we are done.